So in this lecture we are going to see what is secure shell or SSH and some of its benefits. Normally SSH is used for encrypting management traffic, like if we have got any server over here, maybe Linux machine, and it is running SSH server and we want to remotely manage it. Does not matter what client we have got. Let's say this is also Linux or maybe even a Windows machine. So once we establish a connection, remote connection to this machine or the server, if we use telnet connection, then telnet traffic is not encrypted and is viewable by anybody who is sniffing this traffic over here. So if somebody is sniffing this traffic, he would be able to make sense of what is going on through this session. But if we kind of encrypt it using SSH, then there is no way, or it makes it very difficult for the sniffers to decrypt the traffic and then make the information intelligent enough to act upon. Another use of SSH is secure file transfer, where if we are trying to send the traffic or send the file using FTP, somebody can sniff that session and he can, based on that sniffing, he can create the complete file out of it. But if we encrypt that transfer, it would be much more difficult for him to recreate that file because the session would be encrypted. And other use of SSH is secure remote file system mounting. And what it does is that you are aware that we can mount the files in the machines, like or the drives in different machines. Like it would appear to a machine that if that drive is locally present on that machine, but in fact that drive or that directory would be somewhere else on a different machine. But the problem is that once the contents gets transferred from that remote machine to the local machine where that drive is mounted, they can be sniffed in and somebody can hijack that session and steal our important information. But using SSH, we can mount that file system in a secure fashion as well. And other use is encrypted web browsing using SOX protocol. So many great benefits using SSH for our remote management, for secure file transfer, for mounting of remote shares, and for web browsing. So now let's head over to the terminal and see how we can use SSH. Now here I am at my Ubuntu Precise Pangolin, and by default it does not have SSH server, so we can install it. But if you are using Red Hat based distribution like the ones that I've been using, CentOS, which is a derivative of Red Hat Enterprise, then if we install that using default GUI based configuration, then it does install SSH by default as a server, not the client. It's a client and server based protocol. So client is almost always there in all the distributions, but server is not. If you want to install it, you need to install it especially on Ubuntu, that the one I'm using. But on CentOS 7, the server is also gets installed by default. So in case you need to install it on David-based distribution, it's pretty easy. You can simply type in sudo apt get and then the keyword install, and after that whatever program you want to install, we are gonna use OpenSSH server, and after that I press enter, and once it gets done, it automatically starts the SSH daemon service as well. Now before I continue, let me just pull up this whiteboard one more time, and let me explain to you one more important concept, is that I have just installed, let me just grab the pen. So I have just installed SSH server onto, let's say, this machine, which is, let's say it's Ubuntu server, and I am here with the client. Now in case of this encryption, what happens is that this SSH server, it has created a key pair. One of them is public key, and the other one is private key. Now both these keys are totally different. This public key, this is held by the server and is not shared by anybody, but this private key, public key is shared by everybody and not this private key. Private key is held by the server since this is private, and the public key it is given out to the public. It's for anybody. Now what happens is that once these public private keys are generated, although they are totally different, but mathematically they are interrelated. And it means that, let me just draw this one. So this is private, and this is public. So if you have got any file or maybe any characters or any text over here, and this gets encrypted using public key. Now although these two are totally different, but they are mathematically related. So once this gets encrypted and sent over to this entity or this receiver, it decrypts that using its public key and extracts the content. Once it needs to send something to this machine over here, it will do that using its private key. It will encrypt that contents, send it over to this receiver, and this receiver will decrypt it using its private key. Now since the two keys are mathematically related, so both the clients and the server, or both the machines or the end stations, they know that the data that is coming from it has not been tampered with. So it's a good way of establishing not only secure connection, but also a kind of authentication and integrity that the information that is coming from or going to from one station to another or from one entity to another, it is authentic and coming from the reliable sources. So I have come back on my Ubuntu server where we have just installed SSH, and now let's try to SSH this machine for remote management. But before we do that, I have opened up this packet capturing software, which is Wireshark, which is freely available. You can download it, and it's a wonderful piece of product if you want to see and dig deep into the packet that what's going on. Now I'm going to start this packet capturing facility onto the interface, and I bring up this terminal, which is another machine, and now let's try to SSH that server, which is at 192.168.1.20. Now once we do that, it says that the information that we are trying to connect to, that information is asking for a public key, and that public key is not known to us. Do we trust that public key? And in this case I say yes, I trust, because I know that I have just created that key and I'm connected to this machine. So this is something that I should trust. I press yes, and now this key has been added to known hosts file, and I need to give in the password. And now once we are logged in, I can give it the command directory or ls or pwd, and over here the packet capturing software, if I stop this packet capturing and try to capture this session, we see that over here this says that Debian Ubuntu and the SSH protocol is 2.0, but over here we see that we cannot get any sense, we cannot see since I had used these commands and this was displayed to me. If we had been using telnet, we would have seen these directory names and the commands that I've executed over there in this output over here. But since we are using SSH, all this is encrypted. Now let's also try to send a file securely using SSH. So let's bring up this terminal and let's just get out of here. And I'm in this back to my client terminal, and over here I am in lpic directory, and if I type in, let's say ls, we have got this file abcd. Now if I want to securely send this file onto a machine which is running SSH server, there are two ways to do that. I can either use SCP or secure copy, or SFTP, which is kind of interactive way of transferring of file in a secure manner. So let's just try to use SCP. The command is SCP, after that the file name that we want to send, and then the name of the server where we want to send it to. So I type in Ahmed, and this is the username that this machine will connect it. My client will connect using this username. And the IP address is 192.168.1.20, and the file name should be, let's say, abcd. So the same file name which is over here, once it gets transferred to this machine using SSH, it should be named abcd as well. So once I do that, let me just come over here, and if we have got okay, so come back over here and let's just try to do that. Let's press enter, and it is asking for the password, which it should. I give it the password and the file has been transferred. The rate which is 0.0 at the moment is because the file was empty. So if I come over to this terminal and do an ls, we see that indeed this abcd file has been copied. Now we have seen that how we can interactively connect to the machine and give the password and do a secure management of the session of remote machine. But in some cases where we are trying to automate that interaction using maybe a script, maybe we want that certain script should run at a certain point, maybe late night, and certain commands should be executed remotely on that machine. In that case, there would be nobody to type in the password once that prompt come in. So we want that there should be a mechanism that prompt should be bypassed, and not only should be bypassed, but our communication should be encrypted and secure the same way that it was before. So to do that, there is a mechanism where we can create public and private keys on the remote terminal, which is going to connect to the Linux server, and we share our public key with this server. At the moment, what happened when we SSH into this server, it shared its public key with us, but now it's the other way around. We will generate keys on the client machine and share our public key with this machine. And once we will do SSH, since that public key will already be available with this machine, we will not be asked for the password, and we will also see that once we generate those keys, we will not put in any password. So let's just come over here and let me just show you what I'm trying to accomplish here. So the command to do that is SSH keygen, and after that you can give the option like what algorithm it should use and what should be the key of the length of the key, but just let me press enter and we should go with the defaults. I press enter and it is saying that it will create the file public and private key pair and put it in this .ssh folder. So I say yes, go ahead, and it is now asking for the passphrase. Now over here, do not give in any passphrase, just press enter and then enter again, and now the two files, which is one of the private and the other one is public, they have been created. They are placed in .ssh folder, which it has given the path over here, and if I do ls-a, these are the two files that have been created. Now this is the public file, we will not share it with anybody, but this is the private file, my mistake if I said public, and this is the public file which we will share with everybody. So we need that this file be transferred over to this machine. Now we can do that by either, maybe you can transfer it using other methods as well, but SSH gives this facility where we can transfer this file using SSH protocol. So I can do that by typing in SSH and then copy ID -i, which is the input file, which is id_rsa.public, and then where we want it to transfer, which is at this machine .1.20, which is the Linux server or Ubuntu server. So I press enter and it is asking for the password. I give in the password and it says that now we should try to log in. Now if I come over here and do get into SSH and do an ls over here, we see that we have this file authorized keys, which has been automatically created once we executed this command. So once this file was copied over here, it was automatically renamed as authorized keys, and now our public key is in there. If we open up this file and this file, we will see that the contents will be the same. So let's try to SSH now, and Ahmad is the username and just the IP address. So now if I try to do SSH, we should not ideally ask for the password and we will be put right into the prompt. So I press enter and we see that indeed it has not asked for the password, but the communication is still secure. Let's also quickly have a look at the configuration file of SSH daemon or SSH client side as well. So I am here, I am at this remote machine, and if I type cd/etc/ssh, which is the SSH folder, and over here if I type ls, we see that we have got bunch of files. We have got some key files and SSH config and SSH daemon config as well. These keys files, they vary depending upon which protocol we are using. Like we are using maybe RSA protocol, or maybe DSA protocol, or maybe ECDSA protocol. So just let's have a look at this SSH daemon, which is this server configuration file. And if I do vi sshd underscore config, since we are using my own username and not the root, so the file has been opened in read only. If you want to modify some changes, you should use the root credentials or sudo keyword. Now the important thing is the port, that you can change it over here. By default is 22. If you want to listen it to any other port, you can change it to that particular port. Also, if you want to restrict it to listen to any specific IP address of, if you have got many interface cards or many IP addresses assigned to those interfaces, then you want that only specific IP addresses from a specific site should be listening to this SSH request coming from SSH client. You can bind it. At the moment is default, and it is listening to all the interfaces that are attached to this device. So just the important ones are the top ones that I've told you about. If you really want to look into this, you can go ahead, and you are very welcome to do it and see that and change the parameters as per your requirement. For example, we have this logging and authentication, and if we want RS authentication or not. So a bunch of options there that you can tweak or change as per your own requirements. And since it's the configuration file, once you make changes in here, you need to restart the SSH process, which you can do that if we come over here, and if I type in sudo and let's say init control and then restart and SSH daemon or SSH service itself. Now once we do that, I need to give in the password and the service will be restarted.